In this chapter, we will take a look at PLC data memory. Here is the list of PLC data memory for XGI. The range is based on XGI CPU type. There are direct variables and symbolic variables. If a user declares a variable without address, it is considered as symbolic variable, and it will be automatically allocated to A memory. Direct variables use the identifier and address without having to declare the variable name and type. Examples of using identifier and address for each memory will be shown shortly. XGK uses P for both input and output area, where XGI separates input and output area using I and Q as identifiers. M, R, and W are internal data areas used for programming. M is general internal data memory, where R and W are retain memory area. It is to retain the data even when the PLC is powered off. The difference between R and W is that R is used with blocks, where W is used as a whole. F memory is System Flag memory announced by manufacturer. Few examples of frequently used flags are always on, 1 scan on, and 1 second clock. Users can use K memory to operate PID function. There is N memory to save P2P communication parameter. However, users do not use this N memory in programming. U memory is analog data area for special functions such as high-speed counter, positioning, and etc. We will see how to write address for XGI PLC. All memory needs to have a % sign as a prefix. Even if users do not enter %, the software XG5000 will automatically enter the prefix. What comes after % distinguishes which memory it is. First, if it is input memory, it will start with I. And if it is output memory, it will start with Q. After the memory type, it will show the data size. As it's shown, X is for bit, B is for byte, W for word, D for double word, and L for long word. Next is the base number. Base number 0 is the main base with CPU, which means other extension bases with base number from 1 to 7 do not have CPU. The base number comes with a period, and slot number comes after the period. Each base can contain up to 12 slots. Let's take a look at how to write addresses for input and output memory. As we just learned how to write address, IW0.0.0 on the top means the first word of the first slot in main base. Since a word is composed of 16 bits, the first word IW0.0.0 contains from IX0.0.0 to IX0.0.15, which in byte is IB0.0.0 and IB0.0.1. Next word is IW0.0.1. Because the previous word explained, IW0.0.0 contained IB0.0.0 and IB0.0.1, this IW0.0.1 includes IB0.0.2 and IB0.0.3. In bit, it is from IX0.0.16 to IX0.0.31. In double word format, ID0.0.0 means IW0.0.0 and IW0.0.1. Next double word, ID0.0.1, is IW0.0.2 and IW0.0.3. A double word contains 4 bytes, which is 32 bits. On the right-hand side, there is an example of PLC with input and output modules. An input module right next to the CPU is the first slot in main base. Therefore, its module number is 0. As it's written, it is an input module with 64 contacts, which is 4 words. The last bit of the module is IX0.0.63. The second module is output module with 64 contacts from QX0.1.0 to QX0.1.63. The address for the next input module is from IX0.2.0 to IX0.2.63. This is a quiz. Check position of each module through name of modules and assign I/O device from 1 to 6. Number 1 is the 9th bit in slot number 1 in main base, so it's IX0.1.8. Number 2 shows that a byte, which is 8 consecutive bits, are turned on. It is the 4th byte of slot number 1 of main base. Therefore, the answer is IB0.1.3. Number 3 is the 21st bit of the same slot. Therefore, it's IX0.1.20. Number 4. It shows that all 32 bits are on. Since 32 bits can be addressed as a double word, it is ID0.1.0. Number 5. It moves on to 16 contacts output module on slot number 2. All 16 bits are on, so it is QW0.2.0. The last question, number 6, is the last bit on the output module. Therefore, it is QX0.2.15. This is an example of I/O composition. The first slot is equipped with EFM-TB Ethernet module. The second slot is equipped with 32 contacts of digital input module, and the address for the contacts are from IX0.1.0 to IX0.1.31. Next module on slot number 2 is 16 contacts output module. Therefore, the address for the contacts are from QX0.2.0 to QX0.2.15. Next module is analog input voltage type, and this kind of special module does not have allocated address of I/O. The wiring layout is shown on the bottom, and related document can be found in CPU manuals. Internal memory M, R, W area do not need base number nor slot number. Users need to write memory type of M, R, or W after %, followed by data size unit and address. For example, %MX10 is the 11th bit of M area, and %MW10 is the 11th word of M area. Users need to use a decimal to designate a bit address in Word. For example, to express 31st bit of MD2, which is a double word, users need to write %MD2.30. Here is a table showing how the M memory looks like. Each block is a bit, and the first yellow block shown is MX0. The second picture with 8 blocks in the first row is from MX0 to MX7, which is MB0. The third picture shows the whole first row in yellow, which is MW0. The next picture shows that the first 2 rows are in yellow, where the first row is MW0 and the second row is MW1. These 2 words can be assigned as MD0, where D is for double word. At last, all 4 rows are in yellow, which is ML0 where L is long word. Next is about R memory. How to express the address R memory is the same with M memory. The only difference between the two is that R memory is a retained memory. Default setting for M area is not retained. However, if users change basic parameter setting, M area can also be used as retain area. M, R, W area are internal memory, and address format is the same. For example, let's look at M area. The first word for M area is MW0. If MW0 is on, it means that all 16 bits in the first word is on. The first bit of MW0 can be addressed as MW0.0 or MX0. The last bit of the first word can be addressed as MW0.15 or MX15 or MB1.7. Let's look at another example of this bit. First, the starting bit of MW2 is bit 32. The shown bit is 41st, which means its address in bit is MX41. In byte expression, it is MB5.1 because it is second bit of MB5, and in word expression, it is MW2.9 because it is 10th bit of MW2. Additionally, MW2 word is a part of second double word. Therefore, the bit can also be addressed as MD1.9. Lastly, it is the 42nd bit in long word format, so it can be addressed as ML0.41. For the user's convenience, there is an address calculator in Tool menu. If user types in an address, then the calculator shows the address in different data formats. Let's look at another quiz, whether you fully understood XGI Internal Memory. When the system is configured as below, assign internal memory address from 1 to 5. Please stop the video for a second and take your time to take the quiz. When you are done, then continue watching the video. Question number 1 is the first byte of MW63. In order to express the address in byte, multiply the word address 63 by 2, which is 126. So, it is MB 126. Question number 2 is 14th bit of MW66. So, it's MW66.13. Question number 3 is second bit of MW67. So, it's MW67.1. Question number 4 is fourth bit of MW69. So, it's MW69.3. Question number 5 is the whole word of MW71. Answers can also be addressed in bit. However, it is more intuitive to express in word. This is an example of scan program using internal memory. As it's shown in the example, it expresses bit using word or byte. Function move works like copy and paste. In the upper example, when all three contacts are on, data in MW10 is copied to RW10 by move function. The next example shows move function has hexadecimal 1234 for input. When contacts are on, this hexadecimal value is copied to RW20. It's important that the size of data for in and out should be the same. Hexadecimal 1234 is a word value. Therefore, output data RW20 needs to be set as word. If double word data comes for input, memory for output should be set as double word type. This shows differences between M area and R area. R and W area are approximately the same. R area retains data value in case of CPU module reset or when the PLC power is turned off. However, M memory does not retain data value without certain setting. However, M area is also possible to retain data with simple setting. R area is composed of blocks, and one block is 64 kilobytes. PLC flash memory is a memory where data is stored permanently once data is written. When using R device, the user needs to use rset function to set block number. W area is not divided into blocks, therefore does not need to set block number. R and W area are both flash memory, and users can choose to use EBRead and EBWrite functions to write in flash memory. This is a list of System Flag. System Flag is announced by manufacturer and is allocated in F area. For example, in the table, address for one scan on flag is FX155, and users cannot write data in the flag. Another frequently used flag is 1 second cycle clock, which address is FX147. Now, Special Register U area is for analog modules. As it's shown, the size followed by U tells whether the address is a bit or a word. Following the size comes base number, slot number, and data number. Base and slot numbers are automatically allocated depending on where the analog module is equipped at. U area is not automatically registered until users select Register Module Variable Comments from Edit tab. When it is selected, a pop-up message shows that variable comments will be automatically registered according to the module set in the I/O parameter. UW0.0.2 means that there is an analog module in slot 0 in the main base. Variable comment for the device is channel 0 output of analog input module, which means analog data converted to digital data. Each module contains 32 words. This is timer. There are many kinds of timer, including pulse timer, off-delay timer, and integrating timer. However, the most frequently used timer is on-delay timer. When using timer function, keyword T# needs to be used to set the timer. As given in example, T#10S500MS means 10.5 seconds. If MX0 is on for more than 10.5 seconds, the output Q is turned on. This is counter, and there are up counter, down counter, up-down counter, and ring counter. Up counter, down counter, up-down counters are linear counters, where ring counter resets the counter to 0 when the present value reaches certain value. Let's look at an example of counter. This is up counter, and preset value is 5. When input condition is on, counter value increases by 1, and when the current value reaches the preset value, which is 5, then the output Q bit becomes on. When the reset condition is on, the current value resets to 0. One of the benefits using symbolic variables is that it is able to use variable name as comment. As shown in example, motor 10, digital _ switch 1 can be used as variables, and these are automatically assigned to the auto-assigned area, A area. Default format of symbolic variable is VAR, which is local variable only able to be used in that specific ladder program. If a user wants to set global variable that can be used in all ladder programs, the variable needs to be set as var underscore external. var underscore constant is only readable constant variable, and this kind of variable can also be set as global variable by setting var underscore external underscore constant. It is important to note that variables cannot have spaces, but can have underscore. Let's look at examples of symbolic variables. Add variable auto underscore run. Data type is first selected as byte, and if the address is not selected, it will be auto-allocated in symbolic area. Variable emergency underscore stop is also auto-allocated in A area as bool type. Variable temp underscore data is an integer type, which is a word. If a user wants to allocate a memory for this variable, it can be designated as MW10 because it's a word. This will be used frequently when programming. Real type value is frequently used in communication protocol. Then set data type as real and auto-allocate. This is array. Array is a way to declare multiple same type data at once. For example, if MW0 to 4 are declared as array only by knowing the order from 0 to 4 with the name of array, users know which device is selected. When declaring a variable, if array is selected as data type, a window for selecting array dimension pops up. As it's shown below, integer type array from 0 to 9 is selected, and it means that an array with the size of 10 word is selected. If the address for the data is set as MW100, memory from MW100 to MW109 becomes one array. Memory does not have to be selected, and in this case, it can be used with the name of variable. Shown ladder program has move function copying values to variables announced as array. In monitoring window, users can monitor the whole array or each variable. Thank you very much.